Last but not least, let's talk about finding the lengths of a secant segment and a tangent segment that are intersecting. And believe it or not, we will use the exact same formula to find those. You might say, wait a minute, Mr. Fieser, there is no segment BE. How can we use the same formula? Well, let me show you. To do that, we're going to go to our favorite, or maybe one of our favorite websites, www.mathopenref.com. And here you have the situation that we discussed before. Two secant segments intersecting. And if I now move this one secant segment a little bit, then we see that our segments AP and BP change, but you see that the product of the two lengths stay the same because we haven't changed anything about the segment CP and DP, and their product stays the same, so the other product has to stay the same as well. So let's move A and B a little bit more, and as you see, they get closer together. That changes the length of both of those segments, but the product stays the same. And as you can probably guess already, I can get closer and closer, and nothing will change to the product until A and B come to sit right on top of each other. Then we have two segments with the same length, and as we multiply them, we still get the same product. So for our formula, that means we have a segment AE that we are using, and then we have another segment that's also AE that we're using to multiply, and then we have, as we're used to, the segment CE and the segment DE. So essentially this is really all the same, and the only difference is now instead of writing AE times AE, you could write AE squared is equal to CE times DE, and there is your formula once again. Make sure that you memorize it. We talked about it, but it's not any different, and you just have to think it through and you can come up with it yourself. Let's look at our last two examples of the day. Find the value of x as usual. We have a tangent segment with the length 12 times another tangent segment, the same length of 12, and that has to be equal to our external segment x times our secant segment 16. 12 times 12 is 144, and that's equal to 16x. So let's divide both sides by 16, and we get 9 is equal to x, and done. Now stop the video and do the last one yourselves, and then compare your work with mine. Hopefully you came up with the same answer. You got tangent segment 2x times another tangent segment 2x is equal to external segment with 9 times our secant segment, which is 13 units long. 2 times 2 is 4, x times x is x squared. 4x squared is equal to 117. Divide both sides by 4, and you get x squared is equal to 117 over 4. Keep the fraction. And next, we are taking the square root of both sides. So x is equal to the square root of 117 over 4, which you can simplify in the denominator to get the square root of 117 over 2. And that is approximately 5.4. Don't forget the circle around your final answer. Well done, you guys. That's it for today, and I will see you in class.